Okay, we shall start with what we called Pythagorean triplet. So, what is the definition of a Pythagorean triplet? Uh, a triplet xyz in n cube is called is said to be a Pythagorean triplet if we have x, y, z. They are the solutions of this equation. It has very beautiful geometrical interpretation जो हमने अपनी हाई स्कूल क्लासेस में भी पढ़ा. बेसिकली these forms the sides of a right triangle. So when we say that these form what sides or edges of a right triangle, वहाँ पर हमारे पास जो है the length of a side can be any real number, ठीक है. But here we shall restrict ourselves to natural numbers only. That means x, y and z are natural numbers. तो यहाँ पर मैं ये assume करूँगा that we all are equipped with at least basic knowledge of number theory. ठीक है. अब देखो इसके लिए हमारे पास सिंपल इक्वेशन है. इफ़ यू टेक x इक्वल टू 3, 4, 5, दिस इज a Pythagorean triplet. Because 3 square plus 4 square is equal to 5 square. Similarly, if you take 5, 12, 13, it's also a Pythagorean triplet, as 5 square plus 12 square, this is equal to 25, plus 144, this is 169, and this is 13 square. अब यहाँ पर हम देखें 6, 8, 10, this is also a Pythagorean triplet, as this is easy to verify that 6 square plus 8 square equal to 10 square, because 6 square is 36, 8 square is 64, and when we add 36 and 64 we get 100, and that is exactly 10 square. Now there is a relation between this 3, 4, 5 and 6 and 10. We can clearly see that if we take 2 common from this triplet, that exactly become 3, 4, 5. So basically if we take this equation और अगर हम इसको किसी परफेक्ट स्क्वायर से मल्टीप्लाई करें, here remember that x, y and z they are you can say natural numbers. अगर मैं इसको किसी परफेक्ट स्क्वायर से मल्टीप्लाई करूं, से k स्क्वायर, so this is kx square so that means if x, y, z is a Pythagorean triplet, I am writing short form PT instead of Pythagorean triplet, then kx, ky, kz, k is a natural number because I want to restrict myself to n cube, is also a Pythagorean triplet. तो यहाँ पर हम क्या करेंगे, हम एक्स, वाई, जी और के एक्स, के वाई, के जी को अलग अलग ट्रिपलेट नहीं मानेंगे, हम इसको एक ही ट्रिपलेट मान के चलेंगे. ठीक है. तो उसके लिए हम एक डेफिनेशन यहाँ पर लेंगे. अ ट्रिपलेट एक्स, वाई, जी in n cube is called a primitive Pythagorean triplet if number one, it has to be a Pythagorean triplet. That means x square plus y square is equal to z square, with the condition that GCD of XYZ is equal to 1. That means there should be no common prime divisor of X, Y and Z. So in this particular lecture हम यहाँ पर जनरलाइज करेंगे, कंस्ट्रक्ट करेंगे ऑल पाइथागोरियन ट्रिपलेट्स कि अगर कोई पाइथागोरियन ट्रिपलेट है एक्स वाई जी तो उसकी फॉर्म कैसी होगी. ठीक है. सो we have to look for all xyz, possible xyz, such that means such that in, of course, in n cube, such that x square plus y square is equal to z square, and one more condition, GCD of x y z is 1. We shall find this particular set. तो हम यहाँ पर पहला क्लेम कर रहे हैं यहाँ पर that both x and y cannot be even. दोनों इवन नहीं हो सकते. ठीक है. हम इसको प्रूव करेंगे बाय कंट्राडिक्शन. वी सपोज बोथ आर इवन. Okay, then x will look like say 2 times k, y will look like 2 times say m. Of course k and m are natural numbers, positive integers. So x square plus y square will be 4 times k square plus m square. So we can imply this thing will imply that 4 divides x square plus y square, and that implies 4 divides z square, because x square plus y square is z square. That means 2 divides z. Now x has a factor 2, y has a factor 2, z has a factor 2. So GCD of x, y, z, x, y and z all have a prime divisor 2. So GCD cannot be equal to 1, and this is a contradiction. So our claim holds that both x and y cannot be even. Now claim second is both cannot be odd. That means we want to show that हमें ये प्रूव करना है कि उनकी पैरिटी डिफरेंट होगी. दैट मीन्स इफ वन इज ऑड अदर हैज टू बी इवन. सो हाउ वी विल प्रूव दिस? अगेन इसको हम बाय कंट्राडिक्शन प्रूव करेंगे. सपोज बोथ आर इवन. ओके, देन say x equal to some 2k plus 1, y equal to 2m plus 1, say, where k and m are positive integers, or you can say natural numbers. Then the simple calculation, this will become 4k square plus 4k plus 1. This is 4m square plus 4m plus 1. So I am taking 4, this is k square plus m square, this is 4k. So I have taken 4 common, so this is k plus m, and 1 plus 1 is 2. That means if we divide this number by 4, this will be the quotient and this will be the remainder. Okay, so the remainder is not 0. That means 4 does not divide x square plus y square. That means 4 does not divide z square. Now see, x and y, we have supposed that both x and y are even. Sorry, this is not even, this is odd. So both x and y are odd. So x square is odd, y square is odd, and this implies that x square plus y square, which is equal to, of course, z square, this is even. So a perfect square if it is even, then it has to be a multiple of 4. Okay, a simple observation which is a contradiction, because an even perfect square must be a multiple of 4. Okay, so both claim first and claim second, we can conclude from these two claims that both x and y cannot be of the same parity. Okay, if one is even, other one has to be odd. So without loss of generality, we assume that x is even, x is odd and y is even. Okay, then what will be x square plus y square? This is odd plus even is odd. That means z square is odd. So this implies that z must be odd. So this is conclusion till now, that one of x and y should be even, one of them should be odd, and z has to be odd. Okay, now look at this y square. This is of course z square minus x square. This is z minus x, z plus x. Now both z and x are odd. X is odd, z is odd. So odd minus odd is even. So z minus x has to be even, and similarly z plus x has also be even. So I am writing 2 times m in place of z minus x and 2 times n in place of z plus x. So here 2m equal to z minus x and 2n equal to z plus x. So I am writing it in box. I have to use it afterwards. So this is 4 times mn. Okay, that means y square is 4 times mn. Again, it's given that we have already proved that y is even. So y will be of the form 2 times k. So implies that y square will be 4 times k square. Okay, where k is a natural number. So with these two equations, let me name it as number 1. This is number 2. So from first and second, 4 times k square is equal to 4 times mn, and this implies that k square is equal to mn. That's why comparing the two expressions of y square. अब हम यहाँ पर क्लेम करेंगे, claim, this is third claim, that m and n, they are relatively prime. That means GCD of mn is equal to 1. So how we'll prove this? We suppose that there is a common divisor of m and n. Let d be such that d divides m, d divides n. Okay, then d will divide their sum and d will divide their difference, because if a number divides two other integers, then the same number will divide their linear combination also. So I am taking as particular case linear combinations as sum and difference. Okay, so what is sum of m and n? You can write here m is equal to z minus x upon 2 and n is z plus x upon 2. So if you add these, you will get z, and here you will get x. So if d divides both z and x, then d will divide their GCD also. Then d will divides 1, implies d is equal to 1. Here I am using that GCD of z and x is 1. So how this thing came? Okay, let me give a small proof of this. Suppose this is basically straightforward, but I am just for sake of simplification. Suppose GCD of z and x is not equal to 1. That means there is a prime, say P, that means there exists a prime P such that it divides both Z and X. Okay, it implies that P square will divide Z square and P square will divide X square, and this implies P square will divide their difference. The same argument what we used here. That means P square will divide Y square, and this implies that P will divide Y. So look, there is a prime which divides Z, which divides X, and which divides Y. So this implies that GCD of X, Y, and Z is not equal to 1, which is a contradiction. So GCD has to be equal to 1. So what I have used here is basically okay. So that means if there is a common divisor of M and N, it must be 1. ठीक है, तो कॉमन डिवाइजर 1 के अलावा कोई नहीं हो सकता. तो ग्रेटेस्ट उनमें से कोई भी जो है ही एक कॉमन डिवाइजर है, तो ग्रेटेस्ट उनमें से 1 ही होगा. सो GCD ऑफ M and N इज इक्वल टू 1. नाउ K square is equal to Mn, and GCD of M and N is equal to 1. So it's an easy exercise to show that if product of two elements is a product square and the two elements are relatively prime, then both of them have to be perfect square. That means M and N must be perfect squares. This is simple exercise. That means so we can write M like you can say R square, N equal to S square. Of course M and N are relatively prime, so R and S must be relatively prime. That means GCD is equal to 1. Okay, RS belongs to N. Now R square is equal to M, and M is nothing but Z minus X upon 2. S square is Z plus is N, and N is Z plus X upon 2. So if we add these two, we will get Z equal to R square plus S square, and if we subtract these two, we will get X equal to R square minus S square. Okay, so here we get the expressions of Z and X. हमने प्रूव किया था y square is equal to, so this is expression of y is Z, this is expression of X. Also हमने प्रूव किया था y square is equal to 4mn. M is nothing but R square, N is nothing but S square. So this is y equal to 2 times RS. So what's the solution? X is nothing but R square minus S square. Y is nothing but 2 times RS. Z is nothing but R square plus S square. Now what is the condition of R and S? This R and S both belongs to set of natural numbers with GCD of R and S must be equal to 1, and here we must take R greater than S, otherwise this X will become negative. Okay, and R and S must be of different parity. Different parity means if one is even, other has to be odd, otherwise this condition that X is odd and Y is even will not be met. Different parity. So as an illustration, let me take R, S, X, Y, Z. Both must be natural numbers. They must be relatively prime. We have to take R greater than 1, and if one is odd, other has to be even. So let me take S equal to 1. r equal to 2, because any two consecutive numbers will meet these conditions. वो रिलेटिवली प्राइम भी होंगे, ओके, एक दूसरे से बड़ा भी होगा, ओके. So if you take s equal to 1, r equal to 2, what will be x? This will be 2 square minus 1 square is 3, y will be 4, and z will be 5. So 3 square plus 4 square equal to 5 square. This is your first Pythagorean triplet. If you take s equal to 2, r equal to 3, then x will be 3 square minus 4 square is 5, y is 3 to 6 to 12, and z is 9 plus 4, 13. So if you take this 3 and 4, this will become 16 minus 9 is 7, then 24, then 25, and so on. And you know that these are basic. You can take any set of or and these with these conditions, you will get a Pythagorean triplet. Okay, so that's all for today. This is all about Pythagorean triplet, a very beautiful problem of number theory. Thank you very much.